established such a nice thing for us, and that always I remember.
We had a plan quite long time, more than 6 months, that RSET UP Lucknow chapter, RSET Lucknow chapter, ISRS Lucknow chapter will get will request Professor Saumitra Mukherjee for a talk. So today is
No,
the time.
I'm also really very happy to know that you are the chairman of the UP chapter of remote sensing. So it is well deserved because you have done very good work so far.
No, it is not done. Okay, now we will hear from Dr. MS Yadav.
Sir,
Now, Dr. Yadav, what is the status?
sir, within 2-3 minutes, I will start, sir. I am waiting my director. And
Okay.
After 2-3 minutes, I will start.
Okay, we request him that our expert has joined.
Yeah.
And what about Mr. Agarwal?
Agrawal, I was also requested to Agrawal, sir. And I hope he may also join, sir.
His team was there that Professor Saumitra Mukherjee should come. So please inform him. That
Yeah. Actually, sir, Agrawal, sir, he suggested me the name of Professor Mukherjee, sir. So I hope, sir, within 2-3 minutes, I will go to start.
Sure. I'm here, no problem.
Okay, sir.
Please don't make the deviation. So you see in time, the value is there for Professor Saumitra. He's a very
No. It is
Yeah. I understand, sir. I understand, sir.
PhD, Professor Nag and other. It was a meeting for the chair professor.
Yeah.
Chair professor of remote sensing and GIS. It is a national chair professor. So I am one of the experts to select this chair professor and evaluate their work. So I asked the Professor Nag, Prithvish Nag, sir, I have a prior commitment actually today. Please leave me. And the meeting is ongoing, but I left that meeting.
On second, that is the exhibition in Vigyan Bhavan.
Okay.
So it was requesting from our office that I should go. Let's see, I don't know whether I can.
Yes, now the things are pretty good in Delhi. There is no problem so far as the COVID and other things are concerned. Now the things are much improved. You can come. If possible, I will also go there to see you.
But I don't know, I can go only in afternoon. Afternoon, I am having also this seminar. If I can go, I will call you also.
Yes, just inform me. If I find time, I will definitely join you there.
Yes.
काफी लोगों ने ज्वाइन कर लिया देखना कितने पार्टिसिपेंट
30 बस शुरू करें
Dr. Yadav,
Sir.
call your director, let him join.
अच्छा सर
Yeah, sir. He is coming, sir. I hope within 1 or 2 minutes he will join.
Okay. The participants are less. Whether you could arrange for this YouTube live streaming.
Sir, I hope we.
going on.
Yeah.
It's going on,
Hello?
sir.
Going on, very good. Very good. New development.
Yeah. ये स्पीकर है ना वही ये फिर वो भी है दोनों अच्छा सब पता नहीं कहाँ
Please welcome Director Saab.
वेलकम थैंक यू
Welcome
सर
to you in this chapter.
अरे सर
Society. Could you
हाँ
hear
सर
us? Dr.
Society.
Phunkumar, could you hear me?
Yeah.
यस सर मुखर्जी साहब आपसे मुलाकात नहीं हुई थी लेकिन
नमस्कार,
सुनता
नमस्कार।
रहा बहुत जब से मैंने ज्वाइन किया था
सुना आपके बारे में और बड़ी खुशी हुई आज आपसे साक्षात होने की।
हाँ तो
ये गर्व की बात है।
क्या तो क्योंकि सुनता तो था लेकिन कभी ऐसा हुआ नहीं था मेरा
मेरे लिए भी ये सौभाग्य की बात है कि पहली बार आपसे मुलाकात हो रही है।
हाँ कुछ
अच्छा लगा।
कुछ जिम्मेदारियां दी गई हैं तो देखते हैं
नहीं बिल्कुल नहीं you are doing very well your responsibilities. You are doing very well.
तो हल्दर साहब छोड़ के गए जिम्मेदारी, उसके बाद अग्रवाल साहब
और हम तो साथ साथ ही हैं। कई दशक पहले हम लोग साथ साथ काम करते थे।
बिल्कुल बिल्कुल, झांसी में उस समय आप लोग झांसी में थे सर?
मैं हल्दर साहब, अग्रवाल साहब और सरीन साहब, हम लोग एक ही मकान में रहते थे।
अरे वाह,
खाना मैं बनाता था।
अरे सर, क्या बात है, very okay sir. Now we will start sir. Okay sir.
Yes, boss.
Okay sir. On the occasion of National Remote Sensing Day, on behalf of Remote Sensing Application Center Uttar Pradesh and Indian Society of Remote Sensing Lucknow chapter, I welcome all of you audience. Please, my heartiest welcome to Professor S. Mukherjee, Professor of Geology, Remote Sensing and Space Science, School of Environmental Science, Jawaharlal Nehru University, New Delhi. I also welcome to Dr. P. Kumar, Director, Remote Sensing Application Center, Uttar Pradesh, and our Society Chairman, Dr. E.L. Haldar. Today, lecture of Professor Mukherjee, lecture on remote sensing application on Mars and Moon. This is very interesting lecture. In the last, my heartiest welcome to all the audience who attend the lecture. Now, I request to Dr. A.L. Haldar, Chairman of the Indian Society of Remote Sensing Lucknow chapter, to brief some about Science Day celebration and about Remote Sensing Society. Please, Dr. A.L. Haldar, sir. Please, sir.
Thank you, Dr. M.S. Yadav, Secretary of the Society.
Sir, thank you.
Now, it is good afternoon, Dr. Saumitra Mukherjee. We are feeling very, very proud that we are getting Dr. Professor Mukherjee after a long gap as a big man. And also, that our colleague, ex-colleague, Dr. Fulkumar, he's the right man to handle this ARSEC Institute, quite handle. He was so stout fellow, and definitely I feel that he will make the stout of the institute also and the society also. And also I welcome the participant who has joined in this online as well as offline, in that I could see a lot of persons are there in the leader lab, they are sitting and they are contributing. So try to make move some time to time who are presenting in that lab. So I welcome all in this online as well as offline seminar, offline this Science Day celebration. That you know that Science Day, that is the National Science Day, that is on 28th February. It's very, very important day. I hope that each and every student, starting from student to senior citizen, they knows what is the Science Day. That is the basically day in which, that is 28th February, in 1928, Sir C.V. Raman, who discovered the Raman Effect, especially the scattering of light. In this effect, he has seen, in a simple language, I can say, the scattering of light particles by molecules of a medium. This scattering occurs due to the damage, a change in the wavelength of light as it enters the medium. And what Raman Effect says, the Raman Effect, Sir C.V. Raman discovered in 1928 that when a beam of colored light enters a liquid, a fraction of light scattered by that liquid was of different color. Raman showed that nature of the scattered light was dependent on the type of sample present. So this was what Raman Effect. With this, he got the Nobel Prize. And during the this physicist Sir C.V. Raman on 28, he discovered and he got the Nobel Prize on 1930. The National Science Day was declared by the National Council of Science and Technology after a gap of few years. That is, they have designated that day, that is been today, that is on 28th February, that as a National Science Day, which is then the government of India accepted and declared the National Science Day started from 1986. The first National Science Day was celebrated in February 28, 1987. And the theme of the Science Day, time to time it varies. And main theme is total theme is the integrated approach in science and technology for a sustainable future. Every year the theme is vary thoughtfully conceived, keeping in consideration the immediate priorities of the nation, as well as the society, and also world as a whole. Now, in this Science Day, this ISRS Lucknow chapter is going to organize one popular lecture, that is application of remote sensing on the Mars orbital mission, and that is the Mars trajectory, Mars exploration, and this moon. Professor Mukherjee, he kept a vast topic. That was the 3 topics he has included after a gap of 30 years. So what I feel, he will put his significance, that much gap within this 45 minutes. So that is a vast topic. Within that, this Mars orbital mission, that was the thing what he kept on Mars, that in this Mars orbital mission, that is the Mangalyaan, that is the Mars vehicle or Mars craft. That since September 24th, 2014, this Mangalyaan, that is the MOM, Mars orbital mission, is in action, and it was launched on 2013 on 5th November. ISRO, they have launched, and after a gap of almost 1 year, it has in the orbit with the use of PSLV, that is C-25. It was launched on that day, that is 5th November 2013, and finally it was in orbit on 24th September 2014. Since then, it has taken the picture in all round on the Mars, and the main mission of that Mars mission was the exploration of Mars surface feature by studying the morphology, topography, and mineralogy, and study the constituents of Martian atmosphere. And details, our Professor Mukherjee, we can expect that he may give a detailed view using remote sensing technology. And that mission, it was on active till 2021, and 18 July, finally, that Mars Color Camera MCC has captured full disk image of Mars from an altitude of 75,000 kilometer height with a resolution of 3.7 kilometers. And this was the Mars mission. And apart from that, he has included, Professor Mukherjee, that was on Moon. That is, Moon comprises 2 things, that is Chandrayaan-1 and Chandrayaan-2. So that's what I was telling, that Professor Mukherjee, in 3 decades, he has taken 3 things, and he will surprise us with his presence. And this Chandrayaan-1, it was in the orbit near about a year, and it has given the proud of India, and it was, there are a lot of sensors are there from India. There are 5 sensors, and it was also launched by PSLV XL rocket on 22nd October 2008. Prior to MOM, that is Mars orbital mission, it was launched, and from thereafter it was conceived the Moon, that is the MOM, and it was launched, this Chandrayaan-1, in Satish Dhawan Space Center, Sriharikota, on 8th November 2008. After that, in November 14th, that was the main goal was the high resolution mineralogy and chemical imaging of the permanently stored in the north and south polar region. That is the first time that was taken. The mission, the MIT impact was thrown on the south pole. It was thrown quite a height, and it was impacted in a hole that is called Nehru. That is crater, and it was impacted there. And obviously, during that 1 year duration, it has taken a lot of information, and it has given a significant information that molecule of waters within that southern part. And to incomplete work has given to be a full safe on the Chandrayaan-2. That's why it was taken a lot of precautionary measure so that the unfulfilled mission could be completed by the Chandrayaan-2. And that's why it was protected. And the main cause of the damage within a year was the lunar heat. That heat protection was taken in Chandrayaan-2, but due to certain problem means the radiation was happened, but the Chandrayaan-2 was launched equally, and it was launched in proper time. And though it was initially it was a little delayed, but still it was given in the orbit. It was given on the orbit, but at the time of landing of this Vikram lander, this MIT probe, that they have tried that it should be soft landing. The software was designed in such a way that soft landing was there, but before 2.3 kilometer height, it was dejected from the trajectory, and from that the light streaming could not get his proper path, and at that time it was dejected from the path and it was disconnected, the lander. And so this was, of course, Chandrayaan-1 has given a good result, but Chandrayaan-2, due to the incompletion of this MIT probe, it could not. But however, India is success in Chandrayaan-1, and now instead of Chandrayaan-2, again they are planning. India is very much pride and they are very much energetic to put the Chandrayaan-3. Now details will be given by our Professor Mukherjee. We expect, we should learn, we should hear from patiently from that. And I would request to each and every participant, they should join and they should listen properly to Professor Saumitra Mukherjee. And we are very proud that we got this ex-colleague in this day, and as a professor.
No, it's not coming.
And definitely I expect that he justified his presence today. With this, I will hand over the stage to Dr. M.S. Yadav.
Thank
Please.
you, sir. Thank you very much, sir.
Dr. Yadav.
Thank you very much, sir.
Thank you, sir.
Thank you, sir. Now I request to Director Remote Sensing Application, Dr. P. Kumar, address of Chief Guest. So I request to Dr. P. Kumar, Director, sir, please.
Thank you,
Few words.
Yadav, Dr. Yadav. Today we welcome to on Science Day celebration 28th. Today is Dr. Haldar already told detail of the day, about day. We are welcome, Remote Sensing Application Center, all of audience, and I, Professor Mukherjee, he is a senior most our center, and I welcome to him to give him popular lecture on the remote sensing application on Mars and Moon. तो मून एंड मार्स में इंडिया के ही लोगों ने ढूंढा कि पानी है वहाँ पे. तो मेरे समझ ये आएगा कि इस लेक्चर में ये भी आएगा कि पानी के लिए भी कहाँ मैपिंग हुई है, कैसे हुआ, कहाँ पे. तो आई थिंक्स इट इज़ पॉपुलर लेक्चर, मे बी पॉपुलर लेक्चर, और सीनियर साइंटिस्ट हमारे हैं, तो हमारी आज मुलाकात हो गई इसी बहाने ना. और हम रिमोट सेंसिंग सेंटर हमारा बीच में लेक्चर जो है कराता रहता है, सोसाइटी भी, और भी बाकी लेक्चर होते रहते हैं, और कुछ क्यूज और ये सब पोस्टर वगैरह भी चलते रहते हैं रिमोट सेंसिंग पे. तो without wasting time, I hand over to Dr. Yadav.
Thank you very much, sir. And now I request to Dr. Sangharsh Rao to give the brief description of Professor S. Mukherjee. Dr. Sangharsh Rao, please.
Good afternoon, all of you. Much has been said about Professor Saumitra Mukherjee, sir. Saumitra Mukherjee, sir, has done his PhD in geology from Banaras Hindu University. He is also a Commonwealth Fellow, UK. He joined CGWB in 1985 for groundwater exploration and have worked in Sikkim, Andaman Nicobar Islands, Sundarbans and other plains of India. In 1989, he joined our center, our remote sensing application center, Uttar Pradesh, to work in water-starved area like Bundelkhand, Mirzapur, Sonbhadra. He also worked in Delhi, Garhwal, and other parts of Indo-Gangetic alluvial plains. In 1992, he joined Jawaharlal Nehru University JNU to initiate remote sensing center course, and in 2016 he became Dean School of Environmental Science there. He has been collaborating with the universities of Wyoming, USA to develop nanotechnology based devices to remove arsenic from groundwater, which has been published in leading journals. Besides the pioneer work, the initiative of astrobiology terrestrial analog was initiated by him in the last decade, which has been established recently. While working as interdisciplinary researcher, Professor Mukherjee has developed a patented device named SEVAN, S-E-V-A-N, that is Space Environment Viewing and Analysis Network, which was funded by NASA USA to infer the changes in water resources through extraterrestrial changes. During the last 37 years, he has been publishing many books, including he has papers in Nature, Icarus. He has also written 11 books and guided 27 PhD students successfully. He has done about 20 international and national level projects. He is pioneer in moon and Mars study to establish tectonic activity. Some light has been thrown by Dr. Haldar sir. The work on moon tectonics has been published in Nature. This was a very big achievement. IIE Earth and Planetary Sciences and Planets PRL in 2014 to 2021. His pioneer work on Mars has been published in Geomorphology, Icarus and Astrobiology journals in 2020-22. Main importance of his work is the idea that the data were downloaded from Chandrayaan and Mangalyaan, which are Indian satellites. So as we are doing lecture series of ISRS Remote Sensing Center, I think this lecture would be very fruitful when we amalgam all the satellite technology with the work of Professor Mukherjee. Thanks a lot.
Thank you, Dr. Sangars. Professor Mukherjee, really you have done wonderful work, sir. So we are not wasting any time and we are very much eager to listen to you, sir. So you are most welcome, Professor Mukherjee. Please, sir, you will start. Okay, please, sir.
Thank you very much. So today it is also a very auspicious moment for me to speak on science, and that too with in front of our colleagues like Dr. L. Haldar, Dr. Agrawal, and Sri Gulab Prasad ji. He was also my colleague in the Central Groundwater Board and my class fellow in Banaras University. So I invited him also as one of my friends. So the thing is that in last several decades, we all are continuously working, but the thing is that whenever we work one thing, so incidentally or by the grace of God or by the colleagues' help, we get some information of some surrounding other things. So by accident or by some curiosity, some new things has always come up. So I would like to share with you the pleasant findings on the Mars as well as the Moon. So at the outset here, I should thankful to Professor R.S. Chaturvedi, who gave me an opportunity to serve as a scientist in UP Remote Sensing Application Center in 1989, and I am really thankful to him. And at the same time, I am thankful to another person. He is Professor U.R. Rao, because I used to work at my own pace without having any worries or without having any lobbying. But the thing is that I received a phone call from Professor U.R. Rao to join to do some work on moon exploration in 1940. because and that too also by courtesy, by virtue of my association with UP remote sensing, when I was working as a scientist in UP remote sensing. So then we are doing the national hydrogeomorphological map atlas. We are preparing hydrogeomorphological atlas of India. So I was one of the scientists, one of the junior most scientists in Jhansi, working for the preparation of the maps. So then I have a heated discussion with Professor U.R. Rao regarding difference in between alluvium and buried pediment plain. Then he accepted our concept, and then buried pediment plain was introduced in that fluvial hydrogeomorphological atlas of India. So so I am really thankful to Professor U.R. Rao also, because he invited me, but now he is no more, but his blessings are always with all of us. So without wasting much time, I would like to come to the crux of the lecture, that is on Mars and on Moon. So the thing is that when we started working, first of all, I would like to show you some of the slides of the Mars as well as the Moon findings. But before that, I would like to have some preamble about the lunar as well as Martian environment. So the thing is that whatever environment we are enjoying on the Earth, the same environment is not definitely on the Moon. So there was international meeting at European Space Agency, and it was established. It established that there should be different types of noise detection devices for different planets. So I attended that meeting in Germany, in Berlin, and in that meeting some new thought process was evolved. So the thing is that the same interaction of the atmosphere is not there on the Moon as well as on the Mars. So our analytical technique should vary from what we are doing on the Earth. So for identifying different natural resources as well as natural processes, we mainly used the microwave sensor data for the Moon. But for the Mars, we have used some different other sensor data that I am going to discuss with you. But the main finding on the Moon was very exciting. So we are doing our routine job, like trying to identify some of the morphological features on the Moon. But I found out that it appears to be just like a thrust. One rock is trying to slide past away from the another rock, and it is trying to rise above another rock. So then I tried to see some other image also. In that image also I could find the same thing. So there are some approximately 100 locations that I could identify, which shows us that Moon is also having some tectonic processes. Then based on that, some detailed other analytical technique was used, and we used mainly NV software for analyzing the microwave sensor data. And for Mars, our work was continuously going on for identification of some routine work like what NASA has done, and by using our Mars orbital mission data, Mangalyaan data, we are trying to do the same thing. But the thing is that we are having some indigenous sensor also. So in that indigenous sensor, that by help of those sensors, we try to identify some mineralogical variabilities. And by trying to identify those mineralogical variabilities, we could identify some clay minerals. And that clay mineral is smectite. So like we have various other clay minerals, illite, gibbsite, and so many other clay minerals, but there we got the smectite clay mineral. And that smectite is possibly one of the key for our origin of our life. Like we used to say in our common local dialects that पंच तत्व या अधम शरीरा क्षिति जल पावक गगन समीरा, हम सब मिट्टी के बने हुए हैं. And that is actually fact. It has been proved that from clay only the life has been originated. So in this presentation of 40 minutes, I would like to share with you the tectonic activity on the moon, as well as the possible origin of the life on not only on Mars, on different planets, including Earth. So right now, I would like to share with you the slides. Is it visible?
Yeah.
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Okay. So today our point of discussion is remote sensing applications on Mars and Moon. So the extraterrestrial remote sensing is a very fast developing and emerging science. So we are continuously trying to understand the whole universe. But the thing is that because why we need to understand the universe? Because we want to know the Earth in a better way. We cannot create another Earth. But the thing is that if we can come to know the different aspects of other planets, then possibly we can manage our Earth better. So keeping in view the terrestrial analog correlation, the study of Moon and Mars is important. And using our indigenous satellite, Chandrayaan, Moon satellite, and Mangalyaan Mars orbiter probe, when correlated with tectonic framework and mineral distribution on the surface, it has potential to infer the untold science of planetary system. So the thing is that the several journals and books I have consulted, but in those books and journals, I could not identify the proof of tectonic activity on the moon. Even in the first meeting in the ISRO, when I gave my findings, then it was also not believed. It said that no, moon cannot have the three-layer system like Earth, like core, mantle, and crust. But the thing is that then I gathered some more information and published it. And after that, I presented to in front of other ISRO scientists. Then it was appreciated. Microwave sensor, MINISAR, it was one of the tools by which of the Chandrayaan, by which we tried to identify, and this satellite was a boon for our moon mapping, and it was investigated by using the NV software. It is being reported that the geological processes on the moon have found various tectonic features suggesting similar geological activity occurring on the Earth. As at the outset, I said you that there are processes of thrust faulting. So that thrust faulting was possible to identify. The gravity faulting was also possible to identify on the moon. Secondly, in the data from the Mars color camera, MCC, and Dr. Haldar also mentioned about that, MCC, Mars color camera, thermal infrared spectrometer, payload of the Mars orbiter mission was helpful and useful for us to identify some of the mineral assemblages, because some of the minerals we cannot identify by our visible part of the spectrum, near infrared part of the spectrum. For that we need some thermal part of the spectrum also, because some of the minerals they are getting excited and they can be inferred better in the thermal part of the spectrum. Even on the Earth also, in different places, I used to take the thermal camera for ground truth verification, ground mapping. The true color images of the HCC was an innovative idea, and we would recommend the same with perhaps better resolution in upcoming missions. So our main problem was that resolution. It was not having very high resolution. But the thing is that if the same signature we are getting in more than 1, 2, 3, or 4 places, then we are getting our confirmation, because we cannot do the ground verification neither on the Mars nor on the Moon. So we tried to do the terrestrial analog on the Earth. A miniature of the XRF-MS Raman spectrometer may help in detection of the biosignatures intercalated within the rocks. So this is about the Chandrayaan-1, which was launched in 2008 by Indian Space Research Organization. And this is the Mars Orbital Probe MOM Mangalyaan Orbit Trajectory Diagram. So the Chandrayaan-1 was the first Indian lunar probe under the Chandrayaan program. It was launched by the Indian Space Research Organization in October 2008 and operated until August 2009. So all the data that used to be uploaded in one of the site of the NASA. And from that site, we used to take the data, download the data, and we used to analyze the data using our different software. But mainly I use the NV software for that. So the mission included a lunar orbiter and an impactor. So it is the first mission of India to the moon. So the thing is that from our naked eye, from our childhood, we used to see that the full moon, on the full moon day, we used to see that there are some black spots there are on the moon. So it has been said that chand mein bhi dhabbe hote hain. So, and there are different poem and other write-ups also there about the moon. But the thing is that what are those? What are those anomalies within the moon? So that anomaly was different shades, different crests and troughs. That was possible for us to identify by using the microwave sensor data. So the main finding of the historical mission was that the first time it was established that the moon shows the Earth-like tectonic activity. And it was highlighted in the Nature Asia also during that period in 2014. While studying the tectonic activities, it was inferred that lunar volcanic morphological variability is dependent on the number of eruption and its mineralogical assemblages. So it was not found in the equatorial region. So mainly we concentrated on the Schrodinger basin. So this is the south polar region of the moon, which is also known as Schrodinger basin. So the MINISAR synthetic aperture radar imaging radar on board Chandrayaan-1 mission was the first monostatic lunar orbiting synthetic aperture radar. MINISAR data is primarily used to identify signatures suggesting the possibility of the presence of water, ice within the permanently shadowed region of the lunar pole. See that the main objective was that to identify the hidden water resources within the moon. But the thing is that like Earth, the moon is not having the flowing water system. So water molecules are there, but it is hidden within the crystalline rocks. But the thing is that by searching the water, we could identify these structural variabilities. So identification of distinct morphological features in the shadowed as well as illuminated regions of lunar surfaces can be easily done by using MINISAR data. That mainly we have done by using the NV software. The synthetic aperture radar technology can also penetrate the surface, and therefore it is an effective tool to look for hidden fault lines in the shadowed portion on the lunar regolith. Even on the Earth also, if we are using the microwave sensor data, then we have better depth penetration capability. So, this is the polar region showing tectonic activity using microwave sensor data, MINISAR. So here you can see that the earlier studies have tried to study the deformational features such as faults and graben on the lunar crust and compared them to similar features present on the Earth. Another study observed the presence of compressional and extensional features such as lobate strap and gravens on the far side lunar highland, indicative of recent crustal tectonic activity. The features within a real Rima highness located on the near side of the lunar surface showing horizontal displacement of crustal blocks indicative of some shear stress. So the shear stress we could identify there. And that is in all the places, it is not exactly the displacement of the rocks. But there is even the lava flow, that lava flow was distorted. That also it was possible for us to identify by using the MINISAR data. The manifestation of the crustal tectonic activity on the moon in the form of fault and graben due to the above mentioned forces. The previous study investigating lunar tectonic activity have used optical data primarily to study the lunar tectonics. The present work confirms that partially and completely shadowed crater interiors present in the polar regions can also contain unique features indicative of tectonic activity using microwave sensor data such as mini synthetic aperture radar. So here you can see these are the pictures which are obtained by using the mini SAR data, partially shadowed region of the lunar south pole, and the image of the fault running within Cabus B crater and beyond, the image of the debris avalanche possibly triggered from movement along the identified fault, and decomposition image of the debris avalanche, then CPR image of the debris avalanche showing the surface roughness. So relative surface roughness has been assessed because when the snow are old and when the snow are young, that presumes different types of structure. So in the relatively younger snow, they are having hexagonal structure. But if it is older, it is assuming a platy structure. So the differences has been identified based on the spectral response in mini synthetic aperture radar. So this is the region in the south polar region of the moon having the fault and debris avalanche. So like on the Earth also, we are facing some problem in the Himalayan area about the avalanche, but in the moon also, we are having the similar problem like avalanche. It has been proposed that thermal stress may also have been responsible for the lineaments observed on the lunar lithosphere. So the thing is that like in the Earth, inside the Earth, in the mantle, there are different geochemical activities are continuously going on. There is as following the phase rule, P plus F is equal to C plus 2, the phases are changing, the geochemical activities are changing. And from the polylithic basalt or the oceanic basalt, different type of basaltic differentiation are taking place. Similarly, on the moon also, we could identify similar type of basaltic characteristics within the lunar surface. So, the mini synthetic aperture radar onboard Chandrayaan-1 mission is a synthetic aperture radar system which works at a frequency of 2.38 gigahertz S-band with a resolution of 75 meters per pixel from 100 kilometer orbit and a mass of 8.77 kg. It was the first lunar orbiting monostatic synthetic aperture radar flown in October 2008 with a primary scientific objective to detect water ice in the permanently shadowed region on the lunar poles up to a depth of a few meters. It was designed to gather data on the scattering properties of terrain in the polar region of the moon. In brief, the mini-SAR was a single frequency hybrid polarity imaging radar designed to collect information about the scattering properties of the permanently dark areas near the lunar poles at optimum viewing geometry. So this is the diagram of the internal processes. So there is a conveyor belt tectonic system of the Earth during heat out of the planet's interior by the help of convection current. So here the convection current is flowing, but there should be a hot spot. So from where the hot spot is coming, there definitely if the hot spots are generating, that means there must be some geochemical processes are going on. And in the geochemical processes, the phases are changing. The olivine and other minerals, the nucleus, they are changing their phases. And when they change their phases, they are generating the heat. Because whenever, as per the phase rule, P plus F is equal to C plus 2, the energy is generated. When the energy is generated, and that is the hot heat plume, on particular that point, the convection current starts. And it starts rotating, and that is the force of the tectonic activity. So that means the moon is also having similar type of mantle inside the crust. Crust is there, basaltic mainly, and definitely mantle is there. So we are yet to get the sample of the mantle. So I am expecting that someday the mantle samples of the moon will also be collected, and then it will further prove that yes, the moon is also having tectonic activity. So this is the schematic for crust faulting, for block going up or hanging wall, for the block going down or foot wall along the fault plane. So this bold arrows show compression. So on the Earth, same processes we can see in different parts of the Himalayas and other places also, but on the moon also. I was surprised to see that it is also almost the replica of the same process. So the tectonics of the Earth is well established, but lunar tectonics is a new development of science. Recent extension of contractional tectonic features present globally over the lunar surface have been studied to infer lunar crustal tectonism. The investigation of indicators of recent crustal tectonics such as fault lines, thrust fault scraps, and dislocation of debris along the identified fault planes, primarily using data from the miniature synthetic aperture radar, abroad Chandrayaan-1 mission, and narrow-angle camera image are the focus of the study. The spatial orientation of these tectonic features helps to elucidate the change in the interior geological dynamics of any planetary body with time. So the scrap between the Dorsal and Boltzmann craters. So here on the moon you will find mostly the name of the craters are based on some foreign scientists. So the wide angle camera image of the inferred scrap lying between Boltzmann and Dorsal craters and then the narrow angle camera image of the scrap region marked in a white arrow. This is the white arrow. And this white arrows pointing at the scrap footwall, black arrows mark the hanging wall. The narrow angle camera image of the scrap region in B, here it is B. It is white arrows mark the footwall, black arrows mark hanging wall along the thrust fault. The NSE image of region marked in C here, marked in C of partially cross-cut crater within the approximately 200-meter diameter. So here there are various impact craters as well as there are some volcanic eruptions. So first of all, it was very difficult for us to differentiate in between the volcanic crater as well as the meteorite impact. But based on the morphological characteristics, it was clear. So lineaments, not only the crater, but the lineaments which are clear-cut identification of the tectonic activity was also inferred. The ability of the microwave sensor to penetrate the lunar regolith along the application of MX decomposition method on mini synthetic aperture radar data has been used to reveal unique features indicative of hidden tectonics. The MX decomposition derived radar images expose hidden lineaments and lobate straps present within shadowed crater floors as well as over the illuminated regions of the lunar surface. The area around and within Cabeus B crater in the south polar region contains lobate straps, hidden lineaments, and debris avalanches associated with the identified lineaments, which is indicative of a relatively recent crustal tectonism. So it is published in, this work was published in the IEEE Journal of Geosciences and Remote Sensing letter, and the compression mark on the scrap segment, which is showing by the wide angle camera. Here you can see that scrap face clearly. This is the thrust sheet, hanging wall, and this is the scrap face. It has been reported that initially an accumulative tangential thermal stress of 280 bars extension during 4 AE to 3.6 AE and about 540 bar compression from 3.6 AE to 2.6 AE acted upon the crustal mass. It has also been proposed that such kind of thermal stress may also have been responsible for the formation of lineaments or faults observed on the lunar crust. Such lineaments are tectonic landforms which indicate the occurrence of subsurface geologic perturbations as a result of dislocation along fault planes, resulting in surface disruption, evidence of which gets buried over time under the lunar regolith or degraded due to the space weathering. The MX decomposition of mini synthetic aperture radar data has therefore been used to demarcate such hidden lineaments and associated dislocation features in the study region. Here, I suggested that in the next moon mission, that there should be some more advanced sensor should be there, because the thing is that if you see that on the moon or on the earth or on the Mars or any other planet where the volcanic eruptions are taking place, if on the same place more than 2, 3 or 4 volcanic eruptions are taking place intermittently, that means if it is a dormant volcano, then the percentage of titanium dioxide happen to be more. On the earth also, we have seen that while working in the University of Wyoming, we have worked extensively in the Laramie area and the Yellowstone Park. And we have collected the samples and we have analyzed it, and we found out that wherever there are more repeated volcanic eruptions, the titanium dioxide percentage is more. So the same thing happens in the moon as well as on the Mars. But the thing is that exact mapping of this titanium dioxide on the moon was not possible. So in the Chandrayaan 2, it was proposed to have, but that was not possible that time. But it has some other valuable data, so it is being analyzed nowadays. So the lineament and debris avalanches within Crevasse B, wide-angle camera image of Crevasse B crater and surrounding region with the inferred lineament under the white line and the debris avalanche marked with red ellipse B and MF decomposition image of the region in A. Lineament invisible in optical image can be seen lying below the white line. The debris avalanche marked with the red ellipse visible clearly with green pixel from volume. Here it is green pixels. Scattering showing the rough surface due to the debris. A wide-angle camera image of the debris avalanche and MF decomposition of the region of the debris avalanche showing volume scattering indicative of surface roughness. Then CTR image of the region of the debris avalanche showing red pixels. These are the red pixels coinciding with the volume scattering indicative of high surface roughness. The color scale gives the CTR range for only the area covered by the debris avalanche. So this is a clear-cut picture of the lunar tectonics by Chandrayaan initiative. Here you can see this is the line, and here you see this line. So that means clearly there is a shift. So the inferred lunar fault developed by recent compressional crustal tectonic activity lying between Boltzmann and dorsal craters within the lunar south polar region using narrow angle camera images. So the thing is that here we can see there is a clear-cut information. Similar type of information we have identified in more than 100 places within the moon. And it was a rigorous process of analyzing every part of that south pole of the moon. So the first fault in moon inferred by using the Chandrayaan data, the compression marks on scrap segment a wide angle camera image of the scrap region, and B narrow angle camera image of a segment of the inferred scrap marked in a showing compression mark on the surface of the footwall of the thrust zone. So this was also published work. The crustal tectonic activity therefore helps to demarcate the regions experiencing physical and geological stresses within the planetary interior. The geological activity and the related geodynamics lead to the formation of unique features suitably addressed as the surface manifestations of underlying subsurface perturbation. The formation of such tectonic features derived from perturbations along fault is suggestive of the recent crustal movement of the lunar body. Furthermore, the use of radar data can reveal hidden tectonic land deformation possibly formed due to disturbances along the subsurface faults. Application of the MS decomposition technique on mini synthetic aperture radar data effectively helps to demarcate fault lines in shadowed as well as illuminated regions underneath the lunar regolith. Due to the unique capability of microwaves to penetrate the regolith, completely independent of solar illumination. Therefore, using synthetic aperture radar SAR data and the derived parameters, several complex lineament systems portraying the tectonic peculiarities of region can be identified. So it is published in 4 journals in different aspects, and even the physical research laboratories, they have also asked for an invited feature article for their Planix news, and it was a big finding during that period of Chandrayaan, and the ISRO has also included these publications in their into their progress report. So now I'm going to discuss about the Mars. Part 1 is over, Moon, and now we are coming to the Mars. So the study of the Mars was carried out in different morphological units. There was presence of surface water in geological past, so we can see that there are some fluvial geomorphological signatures are there. Like Earth, what we can see the paleo channels, we can see the meander scar. Similar type of information we can also see within the Mars. Here you can see different signatures are there, which are showing that the Mars was having water in geological past. So the location of these features is region specific, and some equatorial regions are showing desert-like sandy dunes presence on Mars. The remnant of old saline lakes was found out as endorheic playa in equatorial region. So we concentrated on the Moon in the South Pole, and on the Mars we concentrated on the equatorial region, because in the equatorial region the relative temperature is very high, and when the temperature is high, the water, the remnant, the water used to be evaporated very fast, and whatever the playa, like in the Rajasthan also you can see the Sambar lake. Similarly in the Mars also some endorheic playa we could identify. The interpretation of this Martian data gives initial information of life support system. Besides water and life, the focus is on the location of safe landing of Martian spacecraft in future missions. So this was also one of our objectives of this ISRO-sponsored project, to identify the suitable landing site of the future Mars mission. So this is the Mars color camera on board the Mars orbiter mission, showing drainage network around the Huygens crater. So Huygens crater we identified our study area. So this is the geomorphological map of the basin of the Huygens crater. Here you can see the basin has been divided into 2 units, basin deposits unit and smooth floor unit. The basin deposit unit constitutes that part of the basin which is not resurfaced. The smooth floor unit is marked by the presence of several craters with layered ejecta, wrinkle ridges, and a dike which runs through the center of the basin. The endorheic playa, which is a proof of old fluvial Mars morphology. The study of Mars was carried out in its different morphological units. There was presence of surface water in geological past, which is recorded as fluvial geomorphological feature on Mars. Location of these features is region specific, and some equatorial regions are showing desert-like sandy dunes presence on Mars. The remnant of the old saline lakes was found out as endorheic playa in equatorial region. So this was our initial finding in 2020, although it was a pandemic, but we continuously downloaded the data and we analyzed. But and we have done some terrestrial analog, some field verification also we tried to carry out. But on the Earth, we tried to identify similar type of features to do the analysis. So this is the formation of the endorheic playa in Mars. The purple and green colored areas, here this is the purple and green colored areas, depict the 2 morphological units. The basin has been classified into smooth floor unit and basin deposit unit, respectively. The layered ejecta craters observed within the basin are highlighted with red arrows. These are the red arrows. The CRISP data set using used during the study are labeled in addition to the different colors outlining their boundary indicating resolution of the image, self full resolution, pink half resolution, and cyan full resolution, and yellow half resolution. So the high-res images overlapping the prism dataset are shown with solid mustard color. So this is also published that in investigation of mineral assemblages in a newly identified endorheic playa near Huygens Basin on Mars and their astrobiological implications. This was published in ICARES journal in 2022 only. So now, recently we identified a very interesting mineral there, that is smectite. So the smectite, which is a clue to the elixir of the life and origin of life. Since the study area is a putative endorheic, it is expected to host clay minerals like iron, magnesium, aluminum phyllosilicates and evaporites such as chlorides, sulfates and or carbonates. The raw radiance data was analyzed to differentiate between actual and spurious absorptions features at 1.9 micrometer and 2.1 micrometer. That means near infrared part of the spectrum, to confirm the presence of only the pixels which showed similar spectrum with radiance and ratioed reflectance were used. Additionally, geological plausibility of these absorption features was associated to confirm their presence. Only the pixels which showed similar spectrum with radiance and ratioed reflectance were used. Additionally, geological plausibility of these absorption features was assessed to confirm their presence. The region has been dated to early Hesperian, a time period when basin is proposed to be hydrogeologically active. So Mars was hydrogeologically active. The minerals were found to be associated with distinct morphological features such as desiccation, polygons or valves and rims of small craters whose impacts may have exposed older surfaces. So these are some of the comparative ratio reflectance and radiance spectral signature of sulfates. It is greater than 0 for both mono and polyhydrated sulfates. Only the pixels which hold similar spectrum with radiance and ratioed reflectance were used. Additionally, geological plausibility of these absorption features were assessed to confirm their presence. So these are some of the image of the process of identification of the minerals. So the spectral signatures and associated morphological features of monohydrated sulfates observed within the basin. Two kinds of monohydrated sulfates were identified in the area with respect to differences in their shapes and band center minima. The spectra of the first and end member were observed to have varying band centers ranging from approximately 2.12 to 2.14 micrometer, very narrow band, and shoulders at 1.95 to 2.16 micrometer were observed in the area. The most commonly observed features was an asymmetric wide absorption band with minima at 2.13 micrometer along with a kink of 2.06 micrometer approximately. So this is the spectral signature and associated morphological features of pH-Z zeolite mixture observed within the basin. So here I would like to point out that where we can expect the zeolite. On the earth also, if you have visited the Konkan coast, you might have identified that there are various places starting from the Bombay to Goa, like Murud, Kasedi Ghat and all these areas, it used to be landslide prone. Why it is landslide prone? Because some of the areas are having the amygdaloidal basalts and some of the areas are having massive basalts. Those areas which are having massive basalt are less landslide prone. But those areas which are having amygdaloidal basalt are more landslide prone. So the presence of this amygdaloidal basalt, which amygdal means the almond shape, जैसे बादाम के shape का होता है, amygdale. So the amygdaloidal basalt, they form when the basalts are coming, basaltic lava are coming from inside the earth or here on the Mars, and they are cooled down very fast, so that the hydroxyl ions and some other vapor, they get escape very fast, and there are some perforations. Perforations are created on the surface of the basalt, and those perforations, if they are submerged within the water, then only the zeolite can occupy. Zeolite is a secondary mineral which is occupying the almond-shaped amygdaloids, which are known as amygdaloidal basalts. So here also we identified the spectral signature and associated morphological features of zeolite mixture observed within the basin. The absorption features in the spectrum match to those of the polyhydrated sulfates such as hexahydrite as well as zeolite such as thompsonite were identified. The spectral signature and associated morphological features of aluminium phyllosilicate and hydrated silica observed within and around the basin. The hydrated silica was found in association with sulfates, as can be seen in the blue spectrum, which appears to be a mixture of these two. Blue and green oval show area from where respective colored spectrum have been recorded from. The black arrow show other locations where 2.2 micrometer features was observed in proximity to sulfate signatures. The spectral signatures and associated morphological features of iron magnesium phyllosilicate deposits in the area around the basin. So here a very interesting observation starts. The FEMG phyllosilicate observed in the area confirmed from the library. So this NV software is having a library, and it can automatically identify the mineral, which is identified as iron-rich smectites. Here you can see this is the iron-rich smectite, clay mineral. The magnesium-rich spectra, we have not collected the samples, we have not analyzed in the lab, but automatically the software, NV, has identified this mineral. And as well as trehinite, that is an inosilicate of calcium, aluminum, and chloride. So the craters around the basin and profile graphs showing their depth. So here a structural uplift of approximately 3.8 km is predicted. Likewise for mineral detected on the rim crater floor pit of the structural uplift is around approximately 2 km. So this is the biosignature preservation potential of smectites. And this is also the Mars 2020 landing site showing biosignatures at Zero crater on Mars. So any future Mars mission will be landed in this site. So which has been identified and recommended to ISRO. And that is up to ISRO that which site they select for landing. From our side, we have given this site for future Mars landing. So the evidence of life on the Mars crater smectites. So life is known to adapt in accordance with its surrounding environment and sustainable resources available to it. Since harsh conditions would have precluded any possible aerobic evolution of life at the Martian surface, it is plausible that Martian life, should it exist, would have evolved in such a way as to derive energy from more optimal resources. Iron is one of the most abundant elements present in the Martian crust and occur at about twice the amount present on the Earth. So the basalts are there on the Earth, the basalts are there on the Moon, the basalts are there on the Mars. But the Martian basalts are different than Earth and the Moon. Iron is more there. The clay minerals contribute to about half the iron found in the soils and sediments. On Earth, clay acts as an electron donor as well as an acceptor in the carbon cycles and thereby supports a wide variety of metabolic reactions. In the context, we consider the potential of iron magnesium smectite, one of the most widely reported hydrated minerals on Mars, for preservation of macro and microscopic biosignatures. We proceed by understanding the environmental conditions during the formations of smectites and various microbes and metabolic processes associated with them as indicated in earth-based studies. We also explore the possibility of biosignatures and their identification within the Mars 2020 landing site, that is also known as Jezero crater, by using the astrobiological payloads on board the Perseverance rover. Smectites and biosignature prevention potential in various environments. In earth-based studies, smectites, clays, aluminum oxides, hydroxides, and associated non-crystalline iron have been found to be primarily binding locations of organic matter. The iron-magnesium smectites form a typical 2:1 clay structure that consists of one octahedral layer stacked between two tetrahedral layers with a negative charge that ranges from 0.2 to 0.6. The negative charge is balanced by large cations such as potassium, sodium, and calcium. A low charge on smectites provides them a higher swelling ability compared to other clay minerals such as illite. So there are, on the earth also we experience different types of clay minerals while putting water, they expand. They are also known as thixotropic clay. Higher expandability also leads to an increased extension. Sorry, I should go fast. The structural presence of clay minerals is known to reduce into iron both biologically and chemically by microorganisms in clay minerals. Two mechanisms have been reported for the reduction of iron in smectites. A wide variety of bacteria and archaea have been identified in different environmental settings that are capable of reducing structural presence of smectites. These include metal-reducing anaerobic archaeobacteria, thermophiles, and hyperthermophiles, and thermonanobacter, geothermobacter, and georegema isolated from oceans and Yellowstone National Park. So it was earlier silver, and this is one of the primary objective of research exploration mission.
Sorry for intervention, Professor Mukherjee.
Yes, I am just winding up.
Please try to
Yes.
try to make it.
The thing is that this is the last slide conclusion.
Okay.
Data from Indian Moon Mission Chandrayaan-1 has revealed a good amount of historic tectonic activity on the lunar surface, very similar to that of Earth. Scientists studying geological processes on the lunar surface now report faults and gravels in partially and completely shadowed crater interior of the lunar polar region. Schrodinger Basin discovery is an eye-opener of global scientific community to strengthen similar studies. Data from Minisar imaging radar on board Chandrayaan-1 mission is primarily used to identify signatures, suggesting the possibility of the presence of water ice within the completely shadowed region of the lunar poles. This data has been used to view various other geological features such as melt flows, crater ejecta blankets, and secondary craters. New satellite data from India's Mars mission Mangalyaan has revealed the possibility of primitive water resource and possibility of origin of life through smectite clay as supporting instrument to develop niche for the life. Jai Vigyan, Jai Bharat. So this is completely Indian satellite data interpreted by Indians but published in foreign journals. Thank you very much.
Thank you very much, sir. Really, you have given wonderful lecture, sir. And I hope this is really very much useful for the students and youngsters. And we also, all the scientists, very much useful and very good information you have given, sir. We all were clapping for you, sir. Really wonderful lecture, sir. और हम लोगों को सर बड़ा गर्व है कि सर आप यहाँ रिमोट सेंसिंग में काम किए हैं सर, और उसके बाद इतना अच्छा काम कर रहे हैं. मुझे लगता है कि हमारे जो यंगस्टर्स हैं सर, उनको बहुत प्रेरणा मिलेगी. और मैं अब रिक्वेस्ट करूंगा डॉक्टर हल्दर साहब से कि मे गिविंग सम कंक्लूडिंग रिमार्क्स. डॉक्टर हल्दर सर, चेयरमैन सर.
Thank you, Dr. Yadav.
Sir.
So for me, how much I'll appraise my friend. But of course, whatever lecture he has given, that is equivalent to the postgraduate level. And even I am also listening very carefully. that what are the findings. So far, I could not observe in this Mars orbiter mission. So that thing he has told, and in the moon, Chandrayaan, he has highlighted definitely that the results of water, it is there, and lot of, he has also published certain papers, and good information he has given to us, especially for the scientific community. So again, we will ask him to request him for future also, but this type of lecture will be very, very helpful for the participant, especially the scientific community and this postgraduate level. And whatever he talked, that is his own findings and own work that he has done. He has motivated from Professor U.R. Rao. Initially, he was Chela of Professor Chaturvedi.
Oh yes,
And
even till today also.
so
Whatever things I owe to him.
he kept their faces in so bright, and he kept the RSET also, that our flag, in high. So definitely a lot of things he told. I cannot appraise all the things because I could not listen each word by word. But of course, certain things I have observed in the Chandrayaan-1, that definitely a lot of things are there, and from his findings, from his visualization, he told. So we are proud on the Chandrayaan-1. Definitely Chandrayaan-2 and 3 definitely will be fruitful in future and that. And what he talked about the Mars mission, that is also, for me, it is a lot of things I have learned, and very good contribution, especially for the center. So with this, I put my thanks to Professor Saumitra Mukherjee that he has given time and very exhaustive talk with that. Thank you.
Thank you,
Professor
sir.
Mukherjee.
Thank you, sir.
What you,
Now I request to audience if any question to Professor
please.
Mukherjee, please. Any audience, any question?
कुछ भी पूछ सकते हैं,
सर
अंग्रेजी, हिंदी, भोजपुरी, किसी भी भाषा
और
में
बाद में भी पूछ सकते हैं, बाद में भी अगर कोई आपकी क्वेरी है, then you will ask to Professor Mukherjee.
मेरे आपके पास व्हाट्सएप नंबर है.
Dr. Ramchand, please.
Hello.
हाँ, हेलो.
Good afternoon, sir. This is Ramchandra from remote sensing.
Namaskar.
Have you detected
Namaskar.
any active snow avalanche there? Like
Huh?
Debris avalanche? Have you detected any snow avalanche like Debris avalanche in moon
In
or
moon,
Mars?
yes. In the lunar.
Yeah.
Yes. In the lunar surface, it was possible to identify some avalanche-like features. And the thing is that the relative density of the solidified ice was different, and based on that avalanche was identified, because on the earth all the time we are doing 10% ground verification, but
Yeah.
on the moon it is not possible to verify, but we have verified it with the L-cross data. L-cross data is a NASA satellite, and we have verified our Chandrayaan data with the L-cross data. And that data also says the same thing. And there are also quite few publications of using the L-cross data by American authors, and they are also saying in the same line that there are avalanches are there. But so far as these tectonic activities are concerned, that is the first time we have reported.
Okay.
So my second question is related to any active volcano is there?
On the moon,
Yeah.
you see that so far as these active volcanoes are concerned, you see its manifestation can be seen by the thermal anomaly as well as some gaseous emanations. But on the moon, unfortunately we don't have the atmosphere. So by any sensor,
Yeah.
it was not possible to identify any thermal anomaly or any type of gaseous anomaly over the craters. But only we have identified in the volcanic craters, we have identified the thickness of the volcanic eruptions, and their different textural variability of the lava. So the textural variability of the lava as well as the thickness of the lava is also giving some clue that some are old and some are younger. But exactly at present, the volcano is active. We have no record of that. We have not identified so far. But that doesn't mean that in future it will not be possible to identify. Definitely, moon is also having some activity, but it is yet to be identified.
Okay, sir. Thanks a lot.
Thank you very much.
Thank you, sir.
Sir, one more question is there by our audience, Jay Mishra. Can we assume about the crystal thickness of moon?
You see, it is varying from place to place. So the thing is that we have mainly concentrated on the south pole of the moon, Schrodinger basin. So the thing is that in the future, in the other missions, there will be some more resolution, that the resolution will be improved, and the exact thickness can be identified in that. So in our project, we have not identified the crustal thickness, but yes, we have seen that displacement of one mass from the other, it is several kilometers. It is several kilometers, the displacement. So that horizontal displacement we have identified, but not the vertical displacement, because there was no penetrating device, unfortunately. So we could not identify.
Okay, sir. I think you just answered the questions. Thank you, sir.
Thank you very much, sir. And I hope this is really very wonderful lecture for all of us. And in future, sir, we will invite you to visit Remote Sensing Application Center, sir.
Oh yes, it will be a pride moment for me also.
Yeah, sir. You are
Yes.
most welcome in the center, sir. Now I request to Dr. Poonam Vasne for vote of thanks. Dr. Poonam Vasne, please.
Thank you, sir, for giving this opportunity. First of all, I like to big thanks to today's speaker, Professor Saumitra Mukherjee, sir, for giving a useful lecture on the topic remote sensing application on Mars and Moon. We must mention our deep sense of appreciation for his great effort, and we are really enlightened with your knowledge, sir. Today's lecture was full of knowledge and interesting things. It gave deep insights into the topics and also revealed some interesting facts. I will like to express our sincere thanks to our Honorable Chief Guest and our Director, Dr. Phul Kumar, sir, for taking out his time from his busy schedule. Thank you so much, sir. I also wish to express my gratitude to Dr. A.L. Haldar, sir, Chairman of Indian Society of Remote Sensing Lucknow chapter, for providing encouragement to whole team for organizing the activity time to time. I also extend my thanks to Dr. M.S. Yadav, sir, Secretary of the Society, for their guidance and enormous cooperations in the organization for every event successfully. Sir, without you, nothing is possible. Thanks a lot, sir. A special thanks to Amit Sinha, sir, Administrative Officer of Center. And I would like to thanks our active members of the society, Dr. Arvind Mathur, sir, Dr. Sri Ramchand, sir. They always shows up active participation in the every program organized by this society. Thanks a lot, sir. I would like to thank Dr. Sangharsh Rao, sir, for his help in the media coverage, and also our treasurer Amresh Singh, sir, for his financial support. Thanks a lot, sir. I would like to thank our executive members, life members, scientists of and principal heads of the department for their active participations. I would like to express my gratitude to all the esteemed delegates and lovely audience of the webinar for their presence and contributions to make this webinar to a great success. Last but not the least, thanks to Amit Yadav for the technical supports, and I would like to thank each and everyone for the involvement and their willingness to take on the completion of tasks beyond their comfort zone. Thanks a lot.
Thank you, sir. Thank you, sir.
Thank you.
Progress, sir.
This is the end of
Thank you, Poonam. अंबानी जी जलपान आप मुहैया करा
दोबारा धन्यवाद करना चाहिए, दोबारा दो बार बुलाए हैं
बहुत अच्छा था।
उस समय खाना खाया
आपको याद ही नहीं था।
इसलिए नहीं याद था वहाँ से क्या गए वो
हम लोग याद रखते जब आप आए तभी के लिए